Hi, so my name is Zenendo. Today I'm going to talk about engineering ethics and robot ethic application of surgical robots and medical device robots. So, what is robo ethics? Robo ethics is applied. Its objective is to develop scientific, cultural, technical tools that can be shared by different social groups and beliefs. And tools are used to promote and encourage development of robotics for advancement of human society and individuals. And mostly this project is going to discuss the engineering ethics for designers, manufacturers, and users, generally humans. But it's also important to take note that robotics is a rather large field. So there's mechanical, electrical engineers, designers, algorithm engineers, software engineers, but this is all encompassing of what engineers in general use and incorporating ethics to make sure they account for this for short-term and long-term issues that it could pose for human beings and minimizing divide. Also incorporating the aspect of morality in all aspects of the robot algorithm and making sure that robot can actually do something completely independent of what the programmer would program onto the code. And then also, they should be able to do self consciously and conduct ethical reasoning and being able to be fully responsible for their actions based on the third term. And then the third term talks about the full moral agents. So this applies to kind of the David Gunkel podcast where they talk about will-based theory and then interest-based theory. But interest-based theory is the one where robots are it's applicable for because another human being will be able to articulate their rights in a court of law. Uh, and this could be done for any other entity as well. Will-based theory is just for humans. They could articulate their rights in a court of law. So the will-based is for humans. Interest-based theory is significant for robots. Then, according to Georgetown Mantra, so I want to make it clear I want to differentiate between medical ethics and then engineering ethics. But they do have a lot of similarities, but it's important to establish them because both of these stakeholders are going to be in the formulation. So there's six different facets: autonomy, benefits, non-maleficence, justice, truthfulness, and dignity in accordance with Georgetown Mantra. So autonomy is basically the will of the patient to either accept or decline treatment. Beneficence is acting in the benefit of the patients. Non-maleficence is not harming the patients. Uh, Justice is making sure being equal to all patients. Truthfulness is a concept of avoiding deception or untrustworthiness. And dignity is just having respect for the patients and the industry as a whole. One example they gave is telecare. So telecare in different countries where uh, they could conduct an operation or give treatment to another country for patients. So, one example they talk about is if a patient needs treatment in another country, that's like life saving, but then that doctor's legal to practice in country A, but not in legal, not, uh, they don't have permission necessarily to do it in or country B. This could cause some ethical issues in terms of legality, liability for the doctor, and other aspects. And advantages, they could do treatment without going overseas, but the disadvantage is the conflict of law that I just talked about, and then potential data compromise because patient records there could also be like written, and then there's going to be a lot more transmission of data. So data could be intercepted, it could be hacked, a whole bunch of other ethical concerns involved. And then this is engineering ethics. To be clear, typically these are not enforceable, or violators typically won't be like they can't necessarily get punished by these agencies, but these are engineering ethics that are all across the board within the industry. But this came from the NSPE websites, at least these six canons. But IEEE ASME also has these similar type of principles, but they might be a little bit wording might be a little bit different. So there's fundamental canons, professional obligations. Then at least on their website they had a few that are based on Supreme Court rulings in terms of how engineers should act concerning certain type of ethical issues. So that's how typically the NSPE guidelines are organized. And then first part of the presentation will have lit reviews that discuss current engineering ethics concerning design and development of surgical robots and biomedical devices. And then the way or the criteria that's going to be used to evaluate and compare between the lit reviews is the significance they bring towards the main concept in the formulation we're going to include in the end of this presentation, and also understanding the results based on the context in which the testing occurred. So sometimes the testing is not necessarily, or not testing, but the case studies are going to be relatively different, the lit reviews, but they all have a significance in terms of the final formulation, and that's how they're going to be used. And then it's also important to differentiate robot ethics and robo ethics. So they're not exactly the same thing, but they're under the same umbrella. But robot ethics is, should the robot conduct a certain action? So it ties towards Asimov's law, first law, second law, and third law. It's just how they should be done. But robo ethics kind of deals more with what I talked about with the different branches, how all the different engineering branches should go with the process of designing and building robots for the future, but also doing it from an ethical standpoint to make sure it minimizes the divide among humans, also making sure the moral aspect, the robot can do the action, and just other aspects that deals with the ethical aspects for design. And then formulation is going to discuss these specific formulations, these five, when and if applicable. And just a little bit of background on surgical robots. They're kind of similar to an autonomous vehicle where level 0 is the lowest, level 5 is the highest, and most surgical robots are level 2 or 3. And some of the common procedures: colectomy, appendectomy, gallbladder removal, hernia removal, spine surgery. There's a lot more, but this is just kind of scratching the surface. At only FDA approved one's Da Vinci robot assisted system, and that's right now level 0, level 1, but it's all FDA approved. It has its controversies, but it also costs $1.5 million. And then there's three facets: controlled, automatic, and semi-automatic for robotic surgery. Advantage is you could do teleoperation from long distance, and then this also accommodates for potential human error, such as missing information for the surgeon's end, lack of attention, and also hand dexterity. So the movement of the surgical procedure could be more accurate than humans. There's evidence that some could be done more accurately than humans, and then another is advanced capabilities. So similar to like FE analysis and engineering, where they could run simulations, this is much more advanced where they could do the entire simulation. They could see and identify and triage root cause analysis behind what type of treatment should be done. A lot of historical trends. These are beyond what humans can do. But disadvantage is expensive overall. There's chance of breakdown and software connectivity issues. It's kind of a new field. Challenges are rising frequently. And then, to put it lightly, there's a lot of issues. There's legal issues, ethical issues, even accuracy, because this is a relatively new field, but it depends on the surgery as well, the specific type of surgery. So a lot of work is still left to be done here. So virtue ethics, deontology, and utilitarianism are the three other ethical frameworks that are talked about. So virtue ethics talks about the characteristics of the moral agents performing an action. So there's also phronesis, there's practical wisdom, eudaimonia, so definition of happiness being over the course of a lifetime of an individual. Deontology is study of duties, obligation, morality of actions without considering consequences or the character of the person performing the action. So there's universal norms, maxims, action that has moral worth. It might be a good action, but it might not necessarily have moral worth. And then also just morality, also not taking emotions. Then utilitarianism focus on right and wrong. Then action based on action based on the fact that if it creates greatest good on the greatest amount of people, that would be more towards utilitarianism. And also there's two types: qualitative and quantitative. So quantitative is based on Bentham's view, based on just quantity of happiness, but then qualitative is incorporated by Mill. So there's two facets to that, and yeah, so that's. But we're gonna kind of keep it simple based, so we're not looking at it from both angles. And Asimov's three laws are: robot may not injure a human being or through inaction allow a human being to come in harm. Robot must obey the orders given by its human except when orders conflict with the first law. And then the third law is self-preservation as long as the first and second law are not violated. And then this is just a picture that illustrates the concept. And next slide. So in this literature review, they believe that the first pillar established is the concept of non-maleficence. So, and this kind of mirrors similar to Asimov's first law. And then another challenge is that typically robots are self-autonomous agents. So this kind of ties towards how they should be trained, like the algorithm and the way you should be training to develop the algorithm. And the idea they gave is it's not going to be the same as you training a dog or the way you teach a child. Given that robots have different capabilities as well, that's what engineers must account, both from a design and ethics standpoint. And then another incorporates the idea of robots in scenarios to prevent harms in the first place from occurring or not acting upon a scenario. So, at least based on the article, if they're not acting on a scenario, that makes them equally guilty. So, example is a surgical sponge. They fail to remove that surgical sponge. That makes them equally guilty from the article standpoint. And second aspect is being able to identify and assess potential harms for a robot to be connected to a patient. So a lot of elderly patients have a chance of being emotionally attached to a robot or like a caretaker robot. One example they gave is Robo. So that's like a therapy dog. And what they're saying is the robot should be able to identify some type of action that could induce some form of harm, emotional harm, and not do those actions in the first place. And then FDA does not, so literature too, this kind of talks about how FDA does not regulate the practice of medicine and does not supervise or provide accreditation for physicians, and it's also responsibility of manufacturer physicians and healthcare for the implementation of these surgical robots. And then what this significance means that there's a little more leeway in terms of both from, and there's good and bad in terms of from a patient standpoint, there might not be certain type of rights, and then also for like surgeons, there's no like accreditation or licensing. So this could cause some harm for patients in terms of like safety. But then the significance of this is if we try to get data from, say, underrepresented communities, it can be challenging if we want to go to the actual countries because the jurisdictional laws are going to be different. So it could be a challenge. It might be able to meet requirements here, but not necessarily in another country as well. From a robo ethics standpoint, there are concerns of jobs being replaced, specifically anesthesiologist, as the article mentioned, and then because there is an automated sedation system that was approved also by the FDA, and then there's three different approaches, and I underlined them and how the article believes that robots should be learning movements, or the Da Vinci robot in particular, how they should be learning. And they talk about it as similar to like an airplane for the first one, where airplane could go on the flight, it could measure its performance metrics and other factors, and then based on that, they could determine and find root cause analysis and find a failure analysis and find exact failure. So similar idea here for the black box approach for the Da Vinci robot. It'll perform the movements and then it'll be able to do a self failure analysis and identify the root cause. And counterposition is that it should actually be learning from another human being, so typically a surgeon. And then based on that, that's how the Da Vinci robot should be learning. And but from an engineering standpoint, they look at it from the big picture. There are ethical risks towards the use of these surgical robots, but there's evidence that they outperform humans. So the cost is, they look at it from like a self-autonomous vehicle standpoint. There are risks, but the overall risk is a small cost towards a long-term benefit, and this also ties towards utilitarianism, as what the article also mentioned. And they envision it kind of similar to a self-driving vehicle where surgeons can be kind of in the driver's seat working with a surgical robot to interfere, or not interfere, but be involved anytime there's problems to best safeguard patients. And this article talks about endoscopic pill. So the way this project or this study occurred is they identified specific metrics of evaluation. But to give a background on this pill, it could basically be used in an endoscopic procedure, and it could deploy drugs in different concentrations fully autonomously during an endoscope procedure. But obviously, there's going to be a wiring attached to that pill. But the pill can deploy the drugs autonomously throughout this procedure and through like a code and built. And then the way they went about this is they got feedback from the stakeholders. They were asking even before the implementation how it would cause some risk to the actual patient. And the goal is obviously to minimize amount of risk. So they set certain type of autonomy. They didn't set full autonomy, but within a scope, they set how much autonomy is going to have by the robot, and then also how much concentration they're going to put for the drug. They also ask questions if the drug is put in this concentration, will it cause some damage or some ripping of certain organs? And this pill can also take pictures of those rips. And the result is that they were successful based on the metric that they established, the pre-identified metrics, and there were no discrepancies with that aspect, and it was able to handle the situational complexity pretty successfully. And also, there was continuous evaluation even after the testing to get feedback from stakeholders, and they're involved in the whole process. It's part of what made this project very successful. And then they also emphasized just starting from an ethical approach from the start of the design to mitigate issues and also ensuring that it aligns with human values to make sure the testing is safe for end user. And then this project is way more comprehensive. This is for a surgical or hybrid surgical robotic system. This is used for orthopedic application in Hong Kong. So the way this one was designed, or at least I'll start here, but on the right, you can kind of see how there are these three different facets that are incorporated. There's professional, business, and design. But the IEC 60601 standard applies to regulatory requirements, which it met. But I want to talk about how they approach it from an engineering standpoint, this project. And to the right is a picture, forgot to mention, but this is a whole schematic. But the way they went about it from an engineering ethics standpoint is they're trying to minimize the amount of human pain that's going to be when the drilling and tapping process occurs, because typically the drilling and tapping needs to occur before surgeons actually put in the screws into actual bones. But the robot is able to identify those exact locations precisely. And the way they went about doing this is they measured different bone densities for different type of samples. And then each of those bone densities are going to have different type of forces required to drill into the bone. There's also different type of linear speeds of the drill. And then they also went further and looked at it from individual components such as controllers, drivers, and motors as part of the design setup. So you can see this is kind of a big setup. There's controllers, drivers, big test setup. You might not be able to see all the equipment, but it's the same concept where they evaluate all aspects of the test apparatus in order to ensure and accommodate for as many patients as possible. So this kind of ties towards utilitarianism to be able to account for different type of patients. Then the conclusion is that this was a successful implementation in the entire R&D process. And one of the reasons is they had a lot of collaboration between mechanical, electrical, industrial, and all stakeholders. And then also there were fewer complications as well as a result of this procedure. So overall, this was successful. And also I wanted to mention that to back up the reliability of the precision points that surgical robots or the surgeons need, they have an accuracy of less than 1 millimeter, orientation accuracy of less than 2 degrees, and temperature change of less than 3 degrees Celsius. And then also it met the Hong Kong Standards and Testing Center requirements. And then this is just going to be more on awareness. This isn't going to be applied in the formulation because this is a lot more comprehensive and it's more large scope and beyond the scope of the project. But this is for the Framingham Heart Study. So this can also evaluate stroke risk and heart disease risk. But the study occurred in 1950 in Framingham, Massachusetts. So essentially, there were 5,000 samples at the time. The concern mainly is at the time the population was 96% Caucasian, while 4% of other ethnicities. So this didn't account for different type of underrepresented communities. And then around 2000 is where the demographics have shifted significantly. So it was about 81% Caucasians at that point, and then 19% of other ethnicities. So there are more sample population for underrepresented groups. Now by 2025, so around this year, this is more at 59% for Caucasians, and then 41% non-Caucasians. So again, more diversity and more underrepresented samples. This is an ongoing study. So even when it was 1950, this is it's like one of its kind. So this, in that sense, a lot of AI, neural networks, a lot of different type of algorithms and stuff used in the healthcare industry ties similar to this in terms of they use these frameworks to find risks, and then they can make automated decisions based on that. But the risk becomes, given that fact that there's 50 years of data skewed towards one ethnicity, this kind of skews the data and doesn't give an accurate representation for underrepresented communities. So say for one ethnicity or an underrepresented group, they're trying to see how long they should be going to the doctor for a certain type of risk for stroke, or they should do a certain type of procedure within the time frame. Might not necessarily be accurate because they might be basing out the Framingham study. Then say they need to go every 4 months, they might say you need to come every 6 months or 2 months. Just give an example, but those are some of the challenges that are encountered with the accuracy of the results. And then one example is this study happened in 2023, 2024, but the study incorporates specific artificial neural networks and trained from the data sets of the Framingham Heart Study and had 42,540 data instances and 15 risk factors. But the study was successful nonetheless at 96.25% and outperformed similar type of test case scenarios and other type of frameworks. So that sense, they still use this, but again, one of the main concerns is to account for underrepresented groups, and some of the biases can cause like differences in sample data, lack of diversity in sample data, inadequate data normalization process, and missing samples or incorrect labels. So these are some of the potential causes for why this is occurring. And then sometimes there's also inherent biases in the software, kind of meant to mitigate future biases or certain type of biases that inherently exist. So those ones are kind of hard to take out or consider because they kind of serve a function, and also it's going to be hard to address those specific type of biases. And then first literature review talks about baseline laws that robots should follow to avoid harming the entities they intend to protect and serve. And then second literature review established the fact that manufacturing designers would account for ethical changes and technical objectives aligned with legal compliance, other countries and jurisdictions. And then the challenges of different regulations can make this challenge. And then from second literature review, it's also different viewpoints on how the Da Vinci robot should learn info from, whether it should be from a human or from itself, through root cause analysis by itself. And then L3 and L4 study. So those two, endoscopic pill and the surgical robot, they showed importance of strong collaboration, and both projects met their requirement. Biggest difference is the scope of a project. Hybridot was much more comprehensive, and it got approval by the Hong Kong government, while the autonomous endoscopic pill was kind of a smaller case study. It wasn't really at a large scale, so scope is vastly different. And then Framingham Heart Study is just kind of more of an awareness. And then I'll discuss these on future slides, so I'll continue on. And then summary is from all these literature reviews, the big takeaways that are going to be used to formulate the ethical questions is concept of no harm. Malfeasance to patients must be universalized throughout the entire surgical process. So this kind of ties towards deontology as well. This is like a universal concept that should just be throughout the whole process, and that should be incorporated within the code. And I'm going to talk about it from how I'm going to do it in the formulation, but this is a big takeaway, just no harm from all those case studies and literature reviews. And then importance of involving all stakeholders in the process of implementation design of a surgical robot during the surgery. So they talked about, at least on both the endoscopic pill and the hybrid surgical robot for the bones. They both had a lot of stakeholders involved, and that's why they're successful. And then it's important to design and implement a surgical methodology considering how it has an impact on the end user in terms of risk and harm. And both case studies for both L3 and L4, this like the endoscope and the bone, they both had this incorporated. And then also, it's important to be aware of the different biases that exist in the software in different contexts and complexities. Literature review gave some suggestions on how the surgical robot should learn hand movement, but this is not going to be discussed because this is a lot of complexity. Like the way the data should be incorporated, if say it was for an international population, say we're looking at data from India, China, and all of Asia. Asia has close to 3 billion people, 4 billion people. So there's not enough case studies, at least based on what I did on the lit review, to make an assessment of how to make a formulation for a surgical robot based on the data in Asia. So it's going to be really hard to universalize the concept. So I'm going to keep that aspect somewhat limited and not go too much into depth with incorporating data from underrepresented communities because that is going to be a much more complex issue beyond the scope of this project. And then some of the questions that were formulated and will be answered in the formulation is main question is how should a surgical robot be designed in a way that goes beyond its current level of autonomy? So this is just a general surgical robot, not accounting for any specific. Example level 1 and 2, while incorporating engineering ethics and minimizing the chance of harm to the patient. And then ethical questions that are going to be analyzed and incorporated to the formulation. So how does the design and coding process of surgical robot ensure the concept of non-malfeasance is upheld and ensures the morality concept of safety of the patient is first importance. All virtue ethics be incorporated into sections of the code to ensure flawless virtues that are consistent with the industry. So we'll incorporate mostly from the surgeon's perspective because the surgeon's going to be working directly alongside the surgical robot. So the goal of that robot should be able to kind of emulate what an actual physician would do and aligning with those ethics. Also, all of the three terms of the roboethics terms in the first slide be applied in roboethics optimal law be incorporated into a hypothetical formulation, designing the surgical robot. And then literature 3 and literature 4 show an importance of all stakeholders being involved in the entire process of designing and implementing a project towards an objective. How will communication between all parties be implemented? And yeah, like all different type of stakeholders are involved in. That's one thing that's going to be incorporated formulation. And then just by me providing this hypothetical scenario, this answers literature two's review in terms of how like a surgical robot should learn behavior for all four aspects. And I think I kind of brushed up on the last slide, but how will data of underrepresented communities be incorporated into the software? This would be on the scope of the project, so there's a lot of complexity of this, so I'm not going to go into that aspect. This one's just more for awareness. And then, okay, this one's the exact same slide, so we're good here. Come on. All right. So this is the formulation. Back to the question. So how should a surgical robot be designed in a way that goes beyond its current level of autonomy, goes past level 2 and beyond? And then, so I'm going to start. First part of the robo ethics is about instruction in the code algorithm, incorporating Asimov's first law to protect the well-being of humans and preventing the divide among human beings and making the well-being of human beings a priority, in addition to other two Asimov law. So first one is the first Asimov is going to be the utmost priority, just not harming another human being. But you can also incorporate the second and third law, kind of based on situational. There might be rare situations where a human's going to actually give an immoral action. It probably won't even happen. I'm not making sureties, but unlikely for that to happen. But they're still going to be incorporated into code, but it's going to be the first law is going to be the first priority. And then based on the second term of the word roboethics, incorporating all aspects of the Georgetown mantra allows for the robot to have a baseline framework and a compliance with a specific industry. Also, engineering ethics in general would also help because the importance would be first would be Georgetown mantra because the surgeon it should be really emulating how the surgeon would go about, but then also engineering is important as well because it could also account for the intricacies, also the different type of materials involved for the organ, how it would react to a certain type of force, the drill, not drill speed, but the amount of force that the incision goes into an organ, it accounts for that, and that's how the movements can be adjusted, and the linkages, the kinematics behind it. So that's kind of engineering, but also from an ethical standpoint. And from an engineering design standpoint, there needs to be safeguards and measures in place in case there's complications. So this is kind of similar to a manufacturing plant where there's a robot and then a human being kind of within the vicinity. It could cause some harm to that worker. So in that situation, that robot's going to stop. Like generally speaking, what like say it's a car factory and they're trying to get seats onto the car, but with the worker being present near that area within like a no-go zone, so to speak, like where they could have some harm. At that point, robot's going to stop. Then typically human would need to engage again. But one of the ways that this could be further enhanced in terms of capability is making sure anytime there's changes or there's discrepancies between what the robot thinks should be done and what the surgeon programmed, there could be communications that are sent to the surgeon. One of the ways is through being able to communicate with that device with doctors, similar to like a text message or to like a computer or to another handheld device, while that surgeon's like say in another ICU attending to other patients. And then that involves IIoT, so Internet Industrial Things. And then to step it up, there's next generation automation systems. Yeah, next generation automation systems that could be integrated to say they want to click on a button, say A, B, C, or D from the text of a phone or from a computer. It would just actuate the action for the robot to conduct the action. And then again, anytime there's discrepancy between the surgeon code and historical data or analytics that the surgical robot has, that should be informed to the surgeon, and then the surgeon could make a call whether they want to go about it. But this basically ties to the concept of maximizing like non-malfeasance, no harm at all to the patient, and the morality aspect of making sure the surgical robot doesn't do something where they're not familiar. Another aspect is if the anatomy is different for the organs and they're just simply not accustomed, at least the robot, based on the alignment of the organs, or say there's bleeding in the organ and that needs to be treated and this wasn't diagnosed beforehand. At that point, it's a morally wise decision for the robot to stop operation to ensure the right procedure is done, as opposed to what the surgeon instructed them to do. And it's also utilitarianism because it protects all the type of patients, given that the robot acts in the best interest of all patients, not just situational based, and it's just kind of as a safeguard to ensure safety of the patient. And then there's ways the physician's not responding to the text or they haven't seen the text, there needs to be a way to contact other type of licensed doctors that can handle this operation. And then they are also contacted in that situation. And then if there's scenarios where nobody's answering the update or any type of adjustments based on the original code, then there should be an alarm system similar to a manufacturing, like a robot. And at that point, it brings attention to like a receptionist, the nurse, another patient could even flag it. I mean, they're going to hear the siren and they're going to be able to tell other people to help. And then also, if there's no one responding, that robot's not going to like operate. The morality is to make sure to minimize the harm to the patient. So if it's safe to stop, they're going to stop an hour, 2 hours, 3 hours, 4 hours, who knows? But as long as it's safe and not harming the patient. But third term of robo ethics, there might be times where they'll have to exercise ethical reasoning self-consciously. So say they stop and they already did an incision, but then the problematic scenario is just there could be excessive blood loss. So say they made an incision and then if they stop the procedure, they could bleed out to death, the patient. So in that situation, that point the robot's going to have to conduct some ethical reasoning self-consciously and then align with the Georgetown mantra and all the other sections that I outlined in the formulation. They have they have to use all those instructions to make sure to make the decision self-consciously. So that ties to the third term of roboethics. And these are just summaries of the different type of theories that are applied. As you can see from the surgeon and then engineering ethics standpoint, there's a lot of similarities. So from deontological standpoint, for surgeons, it's just do not do harm and informed consent to the patient. Engineers look at it from how it should minimize the amount of type of harm that could have on the patient as well through the design, through the type of forces that are implemented into the code, through the sequence, the kinematics behind the actual surgical robot to potentially hit the patient during the course of the procedure, accounting for clearances, positional, you name it, but just try to minimize overall harm. That's just a moral obligation they have as part of the process of engineering. And from a utilitarianism standpoint, the surgeon's going to implement strategies and communicate with the robot in ways that minimize overall risk in that certain surgical procedure, and also while doing that procedure for all human beings. And also, the goal is obviously to minimize the amount of death. So that's going to be for surgeon minimizing the quantity of death. And from engineering standpoint, same concept. The way they design the algorithm to account for and minimize the number of deaths that are possible. So as I mentioned, there is the Framingham study, but it's going to be hard to talk about this in this specific scenario because for accounting for data in Asia, for accounting for Africa, for accounting for South America, different type of countries, the population there's different. There's different type of reactions people might have to the procedure, the amount of forces, the anatomy. A lot of different factors could come into play, and the population, and also how the organs are set up, different type of aspects. So that's gonna be hard to talk about that aspect. But what I'm trying to say is overall, in the course of that procedure, it should be designed in a way to minimize the amount of quantity deaths for human beings in general. And virtue ethics is just character traits in the process of this. So for surgeons, they're acting with kindness, compassion, wisdom, honesty, and in all processes, even during the process of implementing the surgery. Same with engineering ethics. There might be people that are asking about why certain type of actions are being done, their bosses. There could be also other stakeholders curious that are they need to be vested and like there's confidentiality laws obviously, but there's going to be questions in terms of why these are being done from a company standpoint, but engineers need to uphold honesty, wisdom, and then generosity. They need to be able to be transparent in the process that they're implementing. Then both of these industries tie towards a concept of practical wisdom because surgical robots is a relatively new field and there's everlasting changes. There's changes every day and challenges every day, and they're being able to figure this out for even mechanical, robotics, software, you name it. And then eudaimonia is a concept of half self. It's just happiness. So surgeons could find a self of happiness just by being part of this process to being able to enhance the well-being of human beings because statistically there are some procedures where robots are able to handle this better, but then they're getting a sense of life happiness by being part of this process where it could make the life of human beings easier. And then same process with engineers. They're working in areas where they're enhancing human development and human growth. Given this a new field, this is going to occur over the lifetime for some of these people. For some people that are like in their 50s and they are working another 10, 15 years, this could be another life happiness. Aristotle talked about life happiness, but long story short, this has a chance of being for a long period of time, enhancing happiness and a sense of purpose. So it ties towards Aristotle's definition of eudaimonia. And then this is just a large scale application of engineering and medical field in general. So one concern they talked about is just at least I believe it's L2. There was one where they talked about that anesthesiologist potentially being replaced in other type of jobs. So one of the ways this could be combated or addressed is through deliberation and discussions with different type of ethics committees. So there could be bioethics committee, there could be medical, surgical robot committee, mechanical, designers, software engineers. They could all deliberate. There could be conferences that happen yearly. Uh, there could be incentives for people to come. And the more ideas people float around, there's a form of learning within all parties. They'll be able to learn from the differences, the thought processes. Say from a surgeon, they're not going to understand from how an engineer thinks through the process. And then just by talking and deliberation, each party can kind of learn from each other. They can give suggestions, recommendations, look at it from an ethics standpoint. That's where cross communication really helps because it fosters a sense of learning and an innovation that and a form of teamwork and ties to the concept of utilitarianism where it benefits all the different industries and everyone's going to be on the same page and the moral concept of improving human well-being. And that's where there's a strong emphasis on having strong committees and being able to communicate differences. Anytime there's chances of jobs being outright lost, there needs to be ways to integrate those employees and allowing those robots more to serve as an enhancement to making the job easier. At the end of the day, the goal should be to make sure some of those jobs are going to be easier to be done through implementing surgical robots and never as like an outright replacement because through and one concept of robot ethics is to minimize the amount of divide among the population by having robots outright replace a job. Say, I'm just gonna make an example, someone who's 45, 50 years old, they've been working 20 years as a nurse or as a pelvitomist. I don't know how to say that word. Pelvitomist. They get they do incisions and draw blood, but say they've been doing that job for over 20 years. If that job gets automated by a surgical robot, in that situation, they're going to have some other issues because if they're working 20 years, they're going to only have experience in that field. And if this gets automated across different hospitals, they're not going to have certain type of jobs. And another aspect is they won't be able to go back to school after a certain type of age because it might not be feasible for them. And then it causes other issues such as indefinite unemployment. So year and a half, it could be really hard to find another job. And after a certain age discrimination as well, potentially. But these are some long-term issues given the fact that also they don't have skill sets in other areas if they're working 20, 25 years. So it might also be hard for them to change and go to another type of job or industry. So these are some concerns that are outlined. These are bigger picture issues. So long story short, the concept should be to make sure robots are kind of within the working culture and kind of incorporate them so they have a form of like they're kind of similar to humans, but also making sure that they are kind of welcome within the community and also incorporate them to the moral community as best as possible and minimizing human divide through that sense. And the second is obviously with the formulation I described, the morality principle has been upheld. And those are some areas of the robo ethics application from a high level perspective and big picture, regardless. And again, I think I mentioned this doesn't have to be just for anesthesiologists. This could apply for all different aspects in different areas that uses robots in general. And these are all the references that I've used. And that is the end. Thank you for spending the time to watch my presentation. Really hope you learned something here, and hopefully this was informative. And again, can't thank you enough for spending the time to watch my presentation. Thank you.